What's going on, everybody? Welcome back to my YouTube channel. Now we have this question on the board which says solve for the real values of n such that n to the power 6 minus n to the power 3 is equal to 2. Well, our first step will be to move this 2 from the right hand side to the left hand side so that our expression becomes n to the power 6 minus n to the power 3, and as 2 crosses to the left, it becomes minus 2 equal to 0. Now our next step will be for us to express this n to the power 6 in terms of n to the power 3. So this can be written as n to the power 3 raised to the power of 2, because from indices, powers multiply. That means 3 times 2 will also give us 6. So this expression is correct. Minus n to the power 3 minus 2 equal to 0. Now notice that we have a quadratic expression here. So we can therefore say that let n to the power 3 be equal to u. That means wherever I see n to the power 3, I'm going to be substituting u there. So this expression can now be u to the power 2 minus u minus 2 equal to 0. Well, this quadratic equation can be factorized to become u plus 1 times u minus 2 equal to 0. So we have two cases here, u plus 1 and u minus 2. So the first case, u plus 1 is equal to 0, or the second case, u minus 2 is equal to 0. So from this first one, we have u to be equal to negative 1, because as I move plus 1 to the right hand side, it becomes negative 1. Or second case, u will be equal to 2. As I move negative 2 to the right, it becomes 2. So we have two cases. This is the first case and this is the second case. So let's go with the first case. So let's say case 1. For case 1, that is when u is equal to negative 1. But remember that we said let n to the power 3 be equal to u. That means n to the power 3 equal to u. U for our first case is negative 1. So let's put it there, negative 1. So let's move this negative 1 to the left hand side so that we have n to the power 3. And as negative 1 crosses to the left, it becomes plus 1 equal to 0. So now notice that we have sum of two cubes. Well, because 1 can also be expressed as 1 to the power of 3. They are the same thing. So how do we express sum of two cubes? This can be expressed as n plus 1 times n squared minus n plus 1. So this expression, which is sum of two cubes, can be expressed like this, equal to 0. So now we have two cases again. This is the first case, n plus 1 equal to 0, or the second case, n squared minus n plus 1 is equal to 0. So from this first case, we're going to be having the value of n to be equal to negative 1. So this is one real solution for n. But the question is, am I going to be having a real solution for this quadratic expression? Let's see. We're going to be checking for the discriminant. So checking for the discriminant, all right, discriminant is equal to b squared minus 4ac. So discriminant equal to b is negative 1, so that's negative 1 squared, minus 4a, a is 1, that's the coefficient, 1, and c is also 1. Now notice that I'm going to be having, this is 1 minus 4, which is negative 3. So this is negative. So there are no real solutions here. So no real solution. Let me write no real solution. So we only have one real solution from our first case, which is n equal to negative 1. So now let's go and look for our second case when u is equal to 2. So we write case 2. So for case 2, this is when we have u to be equal to 2. Now remember that n to the power 3 is equal to u. But this time, u is 2. Now, we're going to be moving this 2 to the left-hand side so that we have n to the power 3, and as 2 crosses to the left, it becomes negative 2 equal to 0. Now, I want to express this in difference of two cubes because I have a cube here. So how do I do that? It is simply by writing it like this: n to the power 3 minus 2 to the power of 3. But I can't just be putting the power of 3 there without dividing it by 3. Because 3 divided by 3, that's 1. So 2 to the power 1 is still 2. So this is valid, equal to 0. So this can also be written as n to the power 3 minus, now watch, 2 to the power of 1 over 3 to the power of 3. Remember, from indices, the powers multiply. 1 over 3 times 3 is the same thing as 3 over 3. So this is valid, equal to 0. Now we have difference of two cubes. Now let's express this difference of two cubes. So difference of two cubes from this expression can result to n minus 2 to the power of 1 over 3 times n to the power of 2 plus 2 to the power of 1 over 3 times n plus 2 to the power of 2 over 3. So that is it. So we have two cases from here. We have this first case and we have this other case. So from the first case, we see that n minus 2 to the power of 1 over 3 is equal to 0. Or from this second case, n to the power 2 plus 2 to the power of 1 over 3 times n plus 2 to the power of 2 over 3 is equal to 0. So from our first case, we see that n is equal to 2 to the power of 1 over 3. Because as I move this negative 2 to the power of 1 over 3 to the right, I get positive value. And this can be expressed as the cube root of 2. From this second case, we can see that we have a quadratic equation of n. So let's check if we're going to be having a real solution from here by looking for the discriminant. So discriminant is equal to b squared minus 4ac. So discriminant equal to b. b here is 2 to the power of 1 over 3 squared minus 4 times a. The coefficient is 1, so we have 1. And c is 2 to the power of 2 over 3. So we see that this will result to 2 to the power of 1 over 3 times 2, power multiply, we have 2 over 3 minus 4 times 2 to the power of 2 over 3. So obviously, this is larger than the first. So the discriminant is negative. So there are no real solutions here. No real solutions. So we've only got one real solution from case 2, which is n equal to the cube root of 2. So from this whole question, we can see that we only have two real solutions of n equal to negative 1 and n equal to the cube root of 2. And there you have it. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.